Untitled Software Innovator Program. So if you are working on a project and you need our support, maybe hardware access, maybe engineering support, or just to get the word out, please come and contact me. I can help you. This year we are also funding some POCs, and we are looking for developers to come and propose projects to us. So definitely do come and contact me. This is our content focus for 2018. So today we have MEC. We don't have a network slicing topic today, but then MEC. In March we will have a packet DPDK, DDP, dynamic device profiling probably, and security and deep packet inspection, and Intel Select Solutions. April will have a focus on 5G, machine learning, AI, and so on and so forth. So feel free to come back to us if you have any topic ideas you want to speak at these meetups, or of course RSVP on the meetup page for any updates. So agenda for today. After this we'll have Nasser Adas, who is GM Edge and IoT Infrastructure at Intel Corporation, and Anurag Ranjan, System Engineer and Experienced Technology Management Professional, who will be talking about multi-access edge computing, MEC. And then we will have Anurag Agarwal. I'm so sorry. I only saw your .a in the email. From TCS. So he will be doing a talk on centralized emergency traffic optimizer using NEV SDK, and that will be followed on by a hands-on lab. Then we'll have dinner and networking as usual. We always provide food, and it's our birthday party. So we'll also have cupcakes. And then in the evening, we will have two of our partners, Biosoft and Wind River, talk about MEC as well. And then just to increase the fun quotient, we have a fun game. Michelle has created a deck of cards where you actually draw randomly, get a network component, network function, and type of project, and then just for the fun of it, just come up with the idea, and then we have really fun prizes for that. So yeah, looking forward to the whole thing. Okay, yeah, she has prepared a whole slide on that. So I don't know if you have already picked up your card. If you have not, feel free to pick up the card. So you'll have whole day to think about your project. So like I was saying, you'll have a type of project, a network function, and component. So for example, if you got component as DPDK and type of project is enhancement, you probably would want to include DPDK in a network function, which is load balancing, and come up with an idea which is incremental of something which is already existing. You can work individually or as a team. So this will be played in the evening. So with this, I will give the floor to Nasser and Anurag.
Okay, thank you.
One more housekeeping. Since we are streaming online and we are also recording, in case you have questions, please raise your hand. We'll get a mic to you so that you can ask your question, and it's also recorded.
Thank you guys for coming. I'm going to talk about multi-access edge compute. I'm going to do the introduction, and then the technical details will be done by Anurag. We need to put that up front. You can notice. So at a high-level perspective, 5G is bringing the cloud to the multi-access edge. Basically, in the past or the previous technologies, you have to go all the way to the core of the network. But with 5G and the big focus on latency, it is very important to make sure that you actually get access to the data where you need it and when you need it. You need to have that flexibility. Otherwise, just the fact of physics, if you actually have to send the data for a long distance, that could by itself lower the budget of latency. So the whole idea of getting low latency is to be able to access the data, and multi-access edge compute provide you with this flexibility to be able to access the data early on and not having the data go all the way to the core of the network. And also what Intel brings to you, I mean, the cloud technology itself bring it to you at the edge. So you have a consistent platform, you have a consistent architecture that you develop and you deploy from the cloud all the way to the edge and all the way to the device. There are lots of potential opportunities when you actually combine edge compute with cloud-like applications at the edge of the network. That goes from smart cities, connected cars, gaming, and just plenty of opportunities. And I have seen it when I talk to customers. When you actually explain to customers the ability that you actually can provide them with large number of compute on demand, that will actually create quite a bit of innovation in their minds. And they actually have different ways of looking at how to solve the problem compared to what they actually have as of today. As I said, it's very important for a developer to make sure that their investment is really worth it. And from that perspective, we want to make sure that no matter where you actually write your application, no matter how you develop your application, you develop it on the same set of tools and on the same architecture, so you can leverage it all the way from the cloud all the way to the edge of the network. And it is very important for us from a strategy perspective, as I said, to give the developers and the application developers the ability to move compute where they need it and when they need it. And we don't want to have any barriers or restriction from that perspective. So somebody will ask, okay, why should we do edge compute? It's going to depend use case by use case basis, and it has to make sense from that perspective. So there will be a total cost of ownership where you actually put the compute, and also there will be benefits. And so it depends on the use cases, depends on the application. You actually will look at where you want to place your compute. So if you want to actually have a very low latency, you either will put it on-prem or you put it very close to the huts or close to the base station. If you can tolerate more latency, you can put in the local CO where you actually have more space and you can actually put more compute in there. And so you can actually go with it from that perspective. And also it is important to understand that edge compute is not just only about latency. Edge compute will give you the flexibility to basically optimize in cases where you actually have a huge amount of data generated and what the people call the gravity of data. If there is no need to send all this data to the backhaul, there is a cost associated with sending all the data to the backhaul and to the cloud. There is a cost associated with that. And also, there are certain cases when you actually, the reliability of the network is not really there. So you actually will need to do edge compute to actually have consistency and reliability of the network. So there are many potential reasons for somebody to deploy edge compute and not just send the data all the way to the cloud. When people talk about the edge, we have to be open-minded. There are many different definitions of the edge. Most of our focus from networking group is on the telco edge or network edge. But as I said, from an Intel perspective, we are looking at basically deploying compute anywhere, at any time, whenever you need it. So from our perspective, we also look at the edge, be it on-prem, or in the network telco, or in the data center from that perspective. So the breadbox shows the communication service providers view. It's part of their network, and it is the data crosses the point of demarcation to the cloud service providers network. On the other hand, the enterprises, they review their edge as on-prem. And you can see today that companies like Microsoft and Amazon are creating their own light stacks that can sit at the edge. And in their mind, they're licensing that so you can actually put it on-prem, or you can actually put it in the network edge also. So as you can see, the industry is moving into giving you the flexibility to put compute where you need it. I touched about the key drivers for edge compute. And most of you here, if you are developing application for edge compute, you probably have seen this or know about this. So low latency definitely is one of the key drivers. But as I mentioned earlier, the reduction of massive amount of data generated by the IoT devices, which people now call it basically the gravity of data. So you go closer to where the data is generated, and so the data actually basically pull you in closer to where the data gets generated. Of course, there's also data privacy and data sovereignty. So there are certain countries, they have certain restrictions on where the data can go. So you need to localize the data. Also, if you actually in a medical hospital, what have you, there are also restrictions about where the data can go from that perspective. In many cases, they don't want it to really leave the premise from that perspective. Then the other reason for edge compute is context awareness. You can actually provide a better user experience by understanding, where the user is, their location, and also what kind of quality of link he has. And if that really changes dynamically, you can change what you actually deliver to that user. And that's many of the areas where people are doing quite a bit of work to provide a better quality of user experience based on the context of where the user is and the quality of the link and the network KPIs. Also, as I said, scenarios where connectivity is unreliable or limited. So if you're on a cruise ships, you have a satellite link, from that perspective, you try as much as possible to minimize the amount of data that has to go. You only send the data that needs to go there to provide a better quality of experience for the user from that perspective. So from a networking group within Intel, within the data center group, these are the building blocks that we provide to our customers. On the access side, we provide a virtualized multi-RAT software as a reference. We also have that supports both LTE and 5G. We also have basically virtualized for cable, for fixed line. On the edge and the core of the network, we provide a reference for a virtual APC. We also provide our MEC SDK, where Anurag is going to spend some time to explain and provide more detail. Then we also provide and help our customers with the architecture. What kind of CPUs they need, what kind of power profile they need to have in there, what kind of accelerators they need, what will be more optimal for their use case scenarios. And then on the capability enablers, we have visual cloud, so we have computer vision SDKs. We also have some accelerators that helps with integrated GPU inside our CPUs and does transcoding. At the same time, also we have an AI capabilities and big libraries. And of course, all this will end up being with our basically NEV SDN with the cloud-ready networks, where we actually also provide many, and we contribute many to the open source community about the building blocks from that perspective on NEV and SDN. With that, actually, I'm going to have Anurag. I don't want to really bore you with stuff anymore. We'll have Anurag actually dig deep and provide you with more details about our NEV SDK that we provide to the community. Anurag, I'm going to drive the slides. You tell me which slide you want to be on, and I'll take it from there. I'll move the slides for you.
Thank you, Nasser. Okay, so the first slide, let's stick around on the system architecture slide. I want to spend a couple of minutes. So in this particular section, we'll be covering high-level architectural overview, and we will try to get a view that, first of all, let's understand what is MEC. And I'm sure just people have their views, and then most of us are already in agreement. So MEC, and just to make sure that we all are on the same platform. So MEC is a third-party trusted application deployment framework at the edge of the network. So it's for third-party applications and at the edge of the network. And we'll see in this particular section for the technical architects and the product managers and the business leads, what are the contours of the opportunity? So what is in it for all of us? And its relevance for 5G. And then as you'll see, we will briefly touch, in the phase 2 of the 5G, they promise service-based architecture, which opens doors for third-party application developers beyond the traditional telco supply chain. Think what apps did to smartphones. So we could potentially have lots of opportunity coming up for application developers, for different kinds of players in this area. Now let's look at the SC view of what is a MEC system, what are the internals of a MEC system. So this is a block diagram representation, and I'll point you to two key building blocks there. So the first one is the mobile edge host. So that is the host for running third-party MEC apps. And you can see that there is a virtualization infrastructure, and then there is a debate going on, one type of virtualization versus other type of virtualization. So the text is agnostic of that. All that it says is that there is an environment in which third-party applications, MEC apps, can run. There is a control layer there, is part of the MEC mobile edge platform. So there is some control processing going on there. And also, the second important block is outside the mobile edge platform element management. Okay, so these are the two blocks which we'll keep coming back to. Apart from that, there are other elements there which are important especially from NFC point of view, from orchestration point of view, etc. But we'll keep returning to these two. Okay, next slide. Let's go to the next slide. So the next slide. So let me request control so that maybe I can try myself. Yeah. Yeah. Okay. So let's look at for different players and different people, what does it mean? So people with application developers concept, so user experience. So you are an expert in understanding what user experience means, and and you can develop applications around them. So for them, applications and services as MEC applications, there are lots of opportunities there. Next, those who have orchestration, operations management skill set, there are opportunities in this area. Platform companies which have skill set in virtualization, hypervisor, container virtualization, etc. There's lots of opportunity at platform level. And also for the system integration, overall how the different building blocks they work together. So there's opportunity for them. And further, there is opportunity for adjacent DNS providers. And then that comes in because the whole software is getting virtualized. So there is ample opportunities for them to explore adjacent opportunities. Okay. The next slide shows a 3GPP view of MEC, and this is the 4G view. So the previous slide we saw was the internals of MEC, and that is defined by HC. 3GPP view shows how it works with different blocks in a mobile network. So we see the two options. One is when it resides on the S1 interface, and the other one is when it resides on the FGI interface. It is important to also note the second one because it provides an opportunity for IP traffic and for the Wi-Fi connectivity also. to be via the MEC platform. So that's opening more opportunities for different kinds of configurations and deployment scenarios. Next slide, and this is MEC in 5G, and I would like to use a word of caution there. So this is specs in development. This is currently there's only phase 2 of the specs is out, and phase 3 is still under discussion. So this is based on many of the interfaces here are not clear, and that's why I've marked them as FFS. But this is what we think where the discussions is going, where we would still have the traditional division which we are seeing in 5G, which is databases at the top, control layers in the middle, and then user plane layers at the bottom. And then interfaces between the control layers and the user plane layers. It is expected that there will be an application function which will do the control plane signaling, orchestration, management, also have data related to specific applications. And then there will be MEC host which will be shared between the RAN, part of UPF, or the data network. There could also, what I've not shown is the local data network versus central data network. There are multiple networks possible there. Okay, so this is, and the reason why I would like to also mention why this is important is that that the phase 2 of the 5G, I think I did mention earlier, it promises service-based architecture, and especially for the control plane entities where they can query from the port, respective port, and find out, discover the services. And some of the interfaces like N2, N1, N4, they have been discussed, but the interfaces, the MEC-specific interfaces which we expect will be relevant for us, they are still under discussion. Okay. To the next slide. This is specifically for the application developer, and my understanding is that most, if not all of us here, we have interest in application development, and this shows a 3D view of what does an application do. So these are the applications which can be consumer, they can provide a service. What CGPB does is or FC does is provides these platform APIs and the applications and a model. Sorry. And a model in which the applications, they use REST HTTP style APIs to register services for lifecycle management and for different control purposes as well as and they interact with these APIs with the underlying host. Okay, and lastly, what I would like to mention is this is a system integrator view of how multiple MEC, RAN, and core networks would interact with UE mobility, etc. And so the picture becomes slightly more complicated. And this is how people with skill set in this area they could leverage this architecture and then provide additional new kinds of services with UE mobility, with application discovery, with reconnection of UEs, new path discovery, etc. Okay, so this is moving on to the next slide. So you're struggling with the slide navigation. Okay, what is available from Intel? Before we move on to the next section, is there anything you would like to, are there any questions on the previous section? Go ahead. Okay, so I'll take, everyone is in agreement with...
No, 1 second, otherwise there is a question here. 1 second.
Sure.
The question is on the 5G slide. How is the mobility handled on that diagram?
Okay. The key thing is that it is not yet fully defined. This is the stage 2 is what has come out, and stage 3 is still being defined. And I think over next year or so, I think later this year, I think a lot of things will start coming out. Draft specification, and later within a year or so, we'll have more clarity on that.
Right. Do you have any perspective on that? Like,
So so here is what this is the perspective that we think, and this is something that we have had a lot of discussion internally. There are two papers that are going to come out. One is from MEC. One is MEC, how the migration will happen from 4G to 5G, and the other one is how is MEC going to work in 5G. Okay, so a lot of discussion going on internally as well as within the SANS body. And so there is this this is mobility element here. And that information, that mobility information is stored there. And we expect that based on these service points, we will have information flow between those. And also, this interface has not been defined, so there will be information coming through this interface, and also from the control plane, also some information will pass through. Specific details are not published yet. But we expect that these elements, apart from the NEF also, they will be used for discovery and for reconnection and for mobility.
any
Can I answer your
proposals?
question?
Yeah, any proposals on modification of GTP tunnels the way it is today? Are we going to break it?
So that's something that I don't think I've heard anything specifically to that. And there have been offload, local breakout, and then multiple network that has been discussed. I don't remember anything hearing on that specific. Maybe I haven't understood your question. What's the intention of breaking the GTP?
Because when you break the way it is shown here, then you'll be breaking the GTPU segment, and then how do we manage the keys? How do we do authentication? And then anchoring point. There are many issues which every time people come up with. Yeah.
Sorry. So GTPU, and I think so. Let me clarify. So GTPU is from as far as I understand, and maybe what you are saying is GTPU plus IPsec, right? And in that case, there would have I left the call.
No, you're still there.
Okay, that's good. So as far as I know, there is when we talk about MEC, it is expected to reside in trusted domain. So the IPsec tunnel will be outside. Either it will be outside or there will be gateways before this, so that the MEC platform will be actually in a trusted domain. So that's how the current solution is to deal with the authentication and the security keys, etc. As regards the GTP tunnel, so the GTP itself is a very simple protocol, UDP based, etc. And I'm not sure if I understand correctly your concern about opening the GTP tunnel and re-encoding if needed.
Yeah, because when you're processing the packet, you're on the other end of the GTP tunnel. So considering you're bringing it closer, which means you're kind of in between the control plane and the edge axis. So that's the concern that I don't know what is happening. I was just curious to know what is discussed in the standards.
So as far as I know, the GTPU will be happening only in the user plane. So we are talking about GTPU. Sorry, I think I should clarify. We're talking about GTPU, and the MEC host should not look into the control plane packets. And I think that concern may be coming from the control plane user plane separation. And the previous slide where we showed the different architectures, the two possible options. If I can go to that slide, which I can't.
Because today it is anchored at the core, so when there is a mobility from one edge, for example, one eNode B to the other, then it is easy transition. But MEC coming in the middle, it is not clear whether the traffic will pass through it, and then there will be a breakout gateways, or how they are going to manage the tunnel information. So.
Hello, yeah, I'm KRS Murthy. This is not limited to MEC, but I have a general Intel platform question. I'm an M&A mergers and acquisition person, and I'm acquiring a cell tower company, sixth largest cell tower company in the world, and I want to understand what are the tools that are there for the cell tower company to get ready to 5G and maybe beyond, so that we not only remain sixth largest, we move up further. That's the idea. Either you can point to this, or we can discuss offline. Both are.
We can probably discuss offline on that one.
Because there'll be a broader set of things that I'll be looking at. Energy management, because I'm also part owner in a lithium-ion battery company, and how that fits. But is there a lot of management required that can be known to maximize the energy use efficiency? Okay.
Anurag, are you back? She starts moving. Anurag, are you back?
It's still connected up there, so.
He's there.
Can you just let him know that we can't hear him?
Sorry?
Can you let him know we can't hear him? He might be able to hear us, but
He did, but he's not listening.
message him that.
Looks like he's back.
Hi guys,
Yeah, there we go.
All right.
thank you very much. I answered all the questions.
I think
Okay,
maybe we should,
so,
since you're online, I think it's best to finish up your presentation, and then if there's more questions, then they can ask in case we lose you. We better that you finish the presentation. Okay?
Okay.
Go ahead.
Okay, so let me, I think the session marker, I believe, is to share my screen, right?
No, I didn't.
Or did you want me to control your screen? Okay.
You can control.
Okay, that's good. So if you can go into presentation mode, I think I should be might be able to go into presentation mode now. Which one is? Yeah, NASA, your presentation mode is hidden by the.
Yeah, by the.
Yeah, that's my laptop.
You drag it up and then do the presentation.
Okay. Where the presentation?
Okay, that's good. Thank you. Yes. Thank you. Come on. Yes. So what is available from Intel? Now, how do we help our partners and customers? correctly in the right area. Okay, so these are the, also we'll briefly talk about.
Anurag, sorry, a time check. You have like 12 minutes left.
Okay, that's good. Thank you very much. So the history of it is that we had a release 1, which was atom based. We no longer do that. We have now release 2 and release 3. These are Xeon based. With release 3, we also came up with a software only option. The release 2 or the Xeon based is a Wind River bundle, which is optimized for Xeon server and our NICs, etc. And the CentOS one is more flexible. It's tested for Xeon. But what it does is it provides you an environment to develop applications without the dependency of having the right hardware, the Xeon hardware. So that's the advantage. And what is there inside the release? This is the latest release. What's there inside it? So this slide captures the release 3.0 features. So there is a software-only version available. It provides support for both S1 and SGI interface, and support for GTP based on IPv4, etc. VLAN tagging is supported, but editing is not. And then there are reference MM5 APIs supported. We'll have a quick look at which APIs are supported later. There is a logical port abstraction for DPDK, and you could use DPDK or you could work with the OS provided libraries inside the VM, but it is better to use the DPDK because of its efficiency. And we'll briefly also talk about the 4 types of MEC app services supported. So we'll have a more detailed picture of what is internal NEV SDK architecture. Okay. So the MEC specification we saw, this picture captures what is it provided or what is it that we provide in our NEV SDK. We provide on the host side, we provide sufficient environment so you can develop apps. We provide a virtualization environment. This is the ones that are currently published. They are virtual machine based, and there are other alternatives also being worked on. There are APIs for managing those apps, for lifecycle management, and there are some emulation for the virtualization infrastructure management also. So we talked about Wind River bundle, and we also have a CentOS 7 based bundle. So in the Wind River bundle, there are 2 platform solutions. I think the next slide should capture that, which is one for the compute, the other one for the control. NEV SDK is running as a platform. Your VMs applications are running in these VMs. So the controller, this is the ME manager emulator, and then they connect to the eNodeB and the EPC emulators. In our case, we use Polaris. You could use your favorite emulators also. The software only bundle, it provides a way of, integrating on the SGI side, but you could also use with the eNodeB and EPC, but in this case it shows that you have got one hardware and ME emulator is script based on the same platform. Okay, what is the difference between the two in terms of the software stack? This shows a high level view, and I'll quickly summarize. The main difference you will see is the ABS and the DPDK that comes integrated with that for the accelerated virtual switch. This is from Wind River. It has been optimized on our hardware, and it has been characterized, etc., for providing near real-time latencies and the throughput, etc. So we do not provide integrated, at the moment we don't provide CentOS 7 bundle integrated with the OpenVSwitch, but if customers who are developing based on this platform, they are free to use and integrate it and then get better performance in the native CentOS 7 platform. But based on all the work that together with Wind River team and our software engineering team, they have put in for out of the box real-time application, latency, etc. Those are the concerns that this is the right thing. If you are developing applications, if you just want to know that you are using the APIs correctly and you're able to prove that your application itself is working correctly, then you could also go for the CentOS 7. In fact, the newer version of the NEV SDK, the architecture is slightly different, but I wouldn't go into that details now for the because we don't have sufficient time. This is an important picture, so I wanted to spend a few minutes on this one. This shows how the VM applications, they interact with the platform, and how the platform interacts with the underlying OS and the hardware, and that further how it connects with the network traffic. So you have traditional eNodeB to EPC S1 traffic going through. It is what they call bump in the wire configuration, where the packets come in, are processed. The platform decides that these are the packets which is of interest to it, and it further provides to the VMs, or it goes to the egress port especially for the controller user plane separation, where there could be distributed virtualized as gateway and P gateway, and the tab, and you're getting IP traffic. Again, we could look at the IP layers and then do similar filtering. And then something similar also for the Wi-Fi gateway. Now there is option to do a breakout if the rules require. If the configuration is, and this is where specialized handling becomes important for media processing, for content. We talked about streaming earlier. Similar, graphics processing or transcoding or different kinds of application, or for local breakout also, access to the internet. So there is a pathway for that, and we will see the use of this in our architecture next. Okay, so this consists of two platforms: the host and the controller. We talked about the NEV SDK, the NE platform itself. We talked about NE applications. We talked about the various interfaces and how the traffic flows through for GPU and non-GPU traffic. Okay. So this is got too far. Come to that. This is an important picture. We'll come to that. So talked about this. So by default we support, and let me spend 1 minute on this slide. By default we support 4 types of applications. So there is a consumer application and there is a producer application. The producer application provides data and consumer consumes it. The application could reside in a virtual machine, or it could reside on the platform. It could be stored locally, or it could be provided directly. So it's based on where the processing happens, whether in a VM or on the host, where the data is stored, whether inside the VM or on the host, and how it is provided, either directly or through the platform. So authentication is important if it goes via the platform. The next slide shows, so this is the direction we are moving in, and this is where we think that how our edge cloud reference architecture is going to look like. So we'll have on the SIS, and this is many people are interested in such kind of architecture, which addresses earlier question about whether the MEC is anchored close to the core or close to the RAM side. So what we see is that this will be virtualized RAM capability, maybe distributed S&P gateway capability, integrated on the same platform as a MEC, which could also have, and this is a lot of interest coming in from the likes of applications for IoT applications, and Amazon and Azure and Ali kind of cloud service provider, and how the integration will happen. And in this particular case, we expect that this is one possible solution, that we will have wrappers, and then using the breakout, and we will offload those traffics to the respective services, and then further from that they could take it up. Okay. Let's jump to the. Okay, so a quick view of the APIs. So the two different kinds of APIs, MS5 and SD1 APIs we support, and these are all RESTful APIs. There is API programmer's guide that we provide. And these list of APIs, MM5 APIs, is essentially around application lifecycle management, and then live indicator, terminal service management, subscription management, traffic rules management, etc. Okay, this is so these APIs are not 100% MEC compliant because some of them we started developing while the MEC specification were being developed, but it is always a endeavor. We keep making sure that we comply as closely as possible to the MEC specification. So working with us, how does it work? So the way, and this is the process that we are following until now. Things may change later, but at the moment the way we work is that anyone who requests NEV SDK, they go and request for the license from this portal, and then when the portal team provides us the request for the validation and for the to understand what is your requirement, we ask you questions about your project scope, what's your success criteria, your timeline, what kind of hardware you will be using, so that we know that we have tested for that, and in terms of it does not cause problems in using the software, where will it be located so that we can connect you with the right teams, and any context. How does your use of our libraries, it helps us with creating collateral, and that can be used for the community. So these are very important factors. And then we provide, when we accept the license, and we provide your license, and you accept, and we provide you the link to download from Intel portal. Okay? So this is, now let me summarize this quickly. In conclusion, so this is what we have seen in terms of where our NEV SDK is currently being used, from network operators to cabin bodies, equipment manufacturers. Some are creating business value, some are creating opportunity, more of business value, more of opportunity, and there are independent software vendors who are creating both. So community like you create new applications, new business models, and we see there's a lot of interest going on there. A lot of people in different areas they are working on. With that, I will finish my session.
Thank you, Anurag.
Thanks. Okay. Do we have any time for questions?
Yeah, we'll just take maybe one question in the interest of time.
There's one question, Anurag.
Okay. Sure, go on.
What is the perspective on power requirements at the edge? Because some are pushing ARM-based services at the edge, and Intel processors are known to be more power consuming. So what is your perspective on?
So what I would, so there's a lot of different considerations going on, but what we see is what MEC provides you, that virtualization infrastructure, that capability, that flexibility that it provides, and where will you keep that MEC, whether it will be on the, deep in the data center, or next to the edge, whether it is co-located with other VNFs, etc. So when you factor all of that in, and despite all the hype about power, and I think some of that needs to be punctured in terms of there are Xeon platforms which are which give very good performance per watt, and I wouldn't be able to cover that in this. But what I would say is that there are a range of deployment configurations and the kind of flexibility that people are looking for that you would get from Intel architecture, from Xeon platform. And I haven't seen many interest, and maybe there is something that I need to look at about ARM-based systems. And maybe we can think of later, if you want, on interesting applications that are happening.
Yes, I mean, it depends where you deploy and what would be the requirements from that perspective. But if you really need the virtualization, you need basically the scalability to be able to move compute from data center all the way to the edge. It provide the best value. And also, we just announced like the Xeon D family, which is an integrated SoC. And of course, you can go into it depends on what you need. Because we have also the Atom-based, also platform that also provide low power. So we definitely have all the way from the Atom-based, which is low compute, low power, then you can basically scale all the way to the Xeon SP, which give you the best performance from that perspective. So power is going to be a consideration. And
So the release 3 also supports Atom.
sorry?
The release 3.
No, release 3 does not support
It
that.
does not, but I think there is enough there for the community to actually take what we have and actually put it to an Atom based.
Yes, that's right. Yeah.
Okay, thank you. So with that, I'll give the floor to Anurag from TCS. Yeah, thank you, Anurag. I know it's very late for you.
Okay, so feel free to drop me a line if there is something that, any specific question that I might have missed out.
Yeah, sure.
Yeah, thanks, Nasser. Bye-bye.
Thank you.
Let's just make sure it's on.
Yes, I did.
As long as it's got a light on the top.
No.
I just want the switch.
You see agreeing with it.
Oh, he's saying it's good. It's on.
Okay, it's on. Okay. Can start. Okay. Thank you, everybody. My name is.
It's not on.
Sorry. So it's controlling the slides. Yeah, what? I need another one.
Yeah, swap to this one.
Okay. Okay. Which one is this guy? I think let me switch it off.
Okay. And then give you this one.
Okay.
Go ahead and put that one on. That one should. Flip that on. Test. Just say something.
Hello. Yeah. Thank you. Okay. Hello, everybody. My name is Anurag Agarwal, and I work for Tata Consulting Services as a solution architect, and with a prime focus on 5G and its enabling technologies. And I have one of the key technology which I take care of, where we do solutions and prototypes and other proof of concepts. Is the edge computing area. So I personally look into edge computing as well as other enabling technologies, be it network slicing or a bit of IoT as well. So that's where I got some interest on when I was working on IoT. I got interest on how edge computing can help me deploy industry solutions into the field and still be able to utilize my current infrastructure to greater extent, rather than wait for 5G to help me out and start deploying the applications. So as part of this today's session, we have divided the session in basically two parts. First, I'll just cover all the APIs, what Anurag Ranjan has talked about. In the previous session, we saw that reference architecture from Intel, the NEV SDK, and I'll just quickly cover, very briefly touch upon what is MEC, what is NEV SDK, and then I'll just jump into NEV SDK management APIs, which is MM5 interface. Then we will jump into MEApp APIs, which is MP1 interface, and then we'll also go through some of the traffic routing. How do we create routes or traffic routes within the NEV SDK? So we'll also cover those aspects as well. Then we'll give you some time to hands-on. We'll have one server available with us today. Maybe we'll just divide into smaller groups, and collectively we can do some hands-on just to play around how the API is going to look like, and how, if we do application development, what things we need to ensure while we are developing application using NEV SDK. And the last, I'll cover one of the use cases that TCS has developed using this NEV SDK. So moving on. Okay, before we jump into that, I want to show you one of the use cases, what kind of use cases we can develop on the edge computing. I'm pretty sure that all of you must be most of you are working in the edge computing area, so you must be developing very interesting use cases. One of the use cases which I have been working is, how do I optimize my road traffic specifically for emergency traffic, especially in countries where you're or in the cities where your traffic conditions are very, very stringent, especially, let's say, for example, New York or Mumbai or New Delhi, where road traffic is so heavy that it's very difficult, even with all the current available solutions for emergency vehicles to get a pass. It's still very difficult for them to get a free passage. So we have come up with an ideation: can I control this entire infrastructure remotely as well as at my near edge? So typically what happens is, you have mobile tower which typically covers like few hundred meters or few kilometers, depending on the strength. Then, so can I use that edge to control the traffic of that particular area? Can I deploy some applications at my radio edge, so which can have the knowledge of the current traffic situation at that point of time, at that particular place, or that particular signal, and can I route the traffic from there to the remote location using my edge application? So let's see like a traffic scenario. Say I have an ambulance coming in. So how will my ambulance tell where I need to go? So that can be controlled by my centralized analytics engine, a centralized traffic controller. So they as soon as it comes in, it just goes to my radio, and which will redirect the traffic towards the edge traffic controller, which will say, okay, you have this traffic here. It will redirect my traffic lights to tell them you have to switch it on based on what parameters. Okay, it has, number one, all the current traffic, or I can say the car counts, because basically if it's a connected car scenario, so my cars are also talking with my infrastructure, so they would know, okay, how many cars I have at this point in this particular junction, and based on my previous history or daily history, I would know how much time does it take at this hour of the day to clear the traffic from this particular junction. So I can estimate how much time it would need for the ambulance to reach this junction point, and how much time I have to clear this entire traffic. So I can plan it accordingly and instruct the traffic junction or traffic lights to start green signals on the particular direction, so that my entire traffic is clear off, so that once my ambulance reaches there, it does get a free passage. So my edge controller traffic my edge traffic controller will use my another application which is again deployed my traffic radio edge traffic analytics engine, and will instruct back my ambulance and the traffic lights. But at the same time, they will also go back to the entire centralized system, update their system, and it will instruct this entire free passage for my signal. This is just one of the use cases that we have been brainstorming how to solve one of the field problems. So how edge computing can help you there.
So one question there, can you go to the previous slide? What is the difference between the central analytics engine there and the traffic analytics on the edge server?
Yeah, the central, the traffic analytics engine at the edge typically takes care of the traffic signal within that particular scope, because one radio station has a limited radius. So all the traffic signals within that scope will be as a localized analytics. It will be doing only the localized analytics. It doesn't need to send everything back to the traffic controller. depending on the use case, I can still send this information. Say, for example, the number of cars during the day at that particular point. My centralized traffic controller might not need. Depends on how I implement that, what kind of capability I want to add to it. But yes, what we have planned is like you can have the localized analytics at the edge and the central. Then you can just send rest of the information at the central server where you can do the bigger analytics, including all the traffic signals. Yeah.
Would you believe or not, the city of Los Angeles has already done this?
Mm-hmm. Interesting.
Would you believe it or not, but the city of Los Angeles has already done this? They have a very large and a very effective system that I'm aware of.
Interesting. I would love to go in deep into that, because I have been trying to search internet, but I'm not able to find a use case or somebody who has done it this kind of a system. I mean, which is very centralized and using the edge computing as well. So
Yeah.
that's something good to read for me as well. Sorry?
We could talk later.
Absolutely.
I'm KRS Murthy. Las Vegas has done it.
Mm-hmm.
And talk to me, I will give you a big list of the places in China,
Mm-hmm.
in Japan, in Korea, and other places. I personally know what they're doing.
Interesting. Sure. I'll get into it. Okay. Just quickly. We'll quickly touch what is edge computing. I think as explained earlier as well. If I can, so basically if I can bring computing capability at my radio edge, be it carrier or non-carrier, that's we typically called our mobile edge computing, or now it has been renamed as multi-access edge computing. So what all capabilities gives you? It gives you a flexible application deployment and service deployment based on the use case needs. What kind of use case, if it really makes sense to deploy it at the edge, yes, definitely that is the place we can do it. Now, where this edge server can sit, it can sit the proximity of my radio, it can sit at the proximity of my code, depending on what you want to achieve. If it is a very low latency application that we want to develop or deploy on top of them, definitely has to be very, very close to the radio, because there's no point deploying it at the core edge. Okay, so as part of NEV SDK, we will be covering most of the mobile edge host infrastructure here. Now, NEV SDK, I think we have already gone through this architecture diagram in previous session. So we have two major components here: the mobile edge computing platform, which takes care of my multiple services, the traffic rules, the DNS service and the network information service, along with the service registry, which takes care of all my services and application registration management. Along with that, one of the key component is the mobile edge platform manager, which takes care of application registration. Now, as per the current architecture and current implementation, we will go about that in detail in the later part of the session, but for the quick overview, once an application comes up, before that my manager has to go and register it to the MEC platform, so that once application comes up, it can go and tell the platform that I am alive and can you give me a reference ID. So I'll go about those reference IDs and everything in detail in the later part of the session, but for now we'll be covering three major part of this entire architecture. One, the reference point, MM5, which is the management interface between platform and the manager. Second, the platform and the application interface, which is MP1, the reference point. The last, the data plane. So we will also briefly touch upon how the data plane programming has to be done, because we are using the DPDK as part of the data plane here, data plane processing. So we'll just briefly touch upon that as well. Just quickly, the scope of the APIs that we are going to talk about. The scope of the APIs is between ME Manager, ME Platform, and the ME applications. Okay, now let's look at the management APIs. So these are the three major procedures available from management point of view: application configuration, application termination, and connection establishment. So what is application management? When we say application management, application configuration, we talk about once before any application can go live on my radio edge, it first needs to be registered with edge platform so that my edge platform knows about the application. It will authenticate it and it will add key traffic routes. Based on these routes, my network traffic will start moving towards the application or towards the core. So let's pick up application configuration first. Okay, so from an application, as a developer community, it's very important to understand how do I design my application so that once it is registered with the ME platform, I should be able to keep register myself appropriately with the right set of parameters. So on this side of the block shows me what kind of request body should go with me with the application configuration. So once MEM manager registers the application, these kind of so you have to send the application ID, a secret key which is unique to the application, or rather not unique but the private to the application. It can also register for subscribable services. So my application can register itself as an application which will consume the services, or it can produce the services which can be consumed by other applications. So I can subscribe as a producer or consumer. So in this template shows of a consumer. So you can see the provider app ID. So say app ID 2 is the one which will be producing some parameter which I should be able to consume.
Can you give an example?
Sorry?
Can you give an example?
If you go back to the previous application which I just showed in the start, my analytics controller is the producer, where my analytics engine, my analytics engine is the producer, whereas my local controller is the consumer in that case. So it goes and gives the entire analytics data towards my application, the local controller, which it's feed into the local controller so the entire traffic flows via NES in this case. So it will generate traffic based on the traffic it receives. It is also, so it can register as a producer as well as a consumer. So if I have to, I'll get data from the UE, but I'll produce that information to other apps. So I'll process it and send that information to other apps in more sensible fashion. Okay, so, then the another important factor while configuration is the traffic rules. This is pretty important here, because unless until our traffic rules are correct, my data will from the UE or from the apps will not flow towards me. So the certain parameters which needs to be very, very precise. Number one, which VM ID. So once you register a virtual machine or an app, which is typically a virtual machine in this case, you need to provide the MAC address and the VM ID, which is actually registered with my virtual infrastructure. So based on that, my DPDK will know, okay, this is MAC address I'm supposed to send the traffic to. Then there are the certain other parameters like update permitted, yes, or removal permitted. So can application go and update or remove those parameters or update traffic rules in future? There's another, so this is the key, the rule fields. Because the rule fields will tell you, okay, once I receive the traffic, what I'm supposed to do with that. So for the name, there are certain categories like server IP, if it is UE IP or eNodeB IP, or what kind of a protocol I can support. I will go in about them in detail when we talk about the traffic rule creation, but that's something as is a critical part of the application configuration itself. Moving on, application termination. Excuse me. So application termination, when we talk about, it's like ME manager again has to send the termination request. So once ME manager sends a termination request, it's pass on that request to ME app to and sends a notification back. But at the same time, it has to initiate the termination by the application itself. It's not that it will go and abruptly shut down my application. So application has to gracefully shut down. It will wait for a timeout period before it will abruptly shut down. So you can see that in the request body, I have to send the graceful termination timeout period, which is in seconds, and then the app ID. So yeah. So I think I should have put up this before the termination. The manager connection establishment, this is an interesting API basically. So once ME manager comes up, it has to go and register itself for any notification coming from platform. So if it needs any notification, it should have first registered itself as a listener. So once you initiate the notification request, it will go and open a WebSocket with the application. And once it opens a WebSocket application, whenever there's a new notification which is supposed to go for ME manager, it will immediately forward it to ME manager. So for example, once if I roll back to the previous slide, if you look into this slide, the last line, the termination notification. So even though it has got the termination response, but once the app goes down, it gracefully shut down, it will still get a termination notification that this particular app has gone down. So that from a management point of view, I should be able to manage the current state of each application and services deployed on my infrastructure. Okay, let's jump to ME app APIs. So these are the current APIs available from an application point of view. The first is live indicator. So I'll go about them in detail in subsequent slides. Let me just fast. Okay, the live indicator. Okay, now this is one of the important APIs for application point of view. Once an application is registered by ME app, so it first has to fire this API to get the reference ID, which is more like an authentication. Once it registers itself, it will come back with the reference ID, something like this at the bottom of the screen, which has to be used in all the subsequent requests. Unless until you have this reference ID, it will not be able to authenticate, or the ME platform will not know if you are already registered with me or not. So all you need to send is the application ID, the same secret key what my ME manager has sent during the application registration or application configuration, and what type of ME app it is. Is it an ME app or ME app service, as we spoke in previously. So it can register it as an ME app or ME service, which is a producer or a consumer. Similarly, I can delete. So once I deregistered, it will send a termination request, as we saw in the previous ME manager's termination request slide. Now that was initiation by the ME manager. The same thing can be done by ME app. ME app can also initiate the termination request. So same rules applies here. It will send a termination indicator. Once I get the response, it will notify all the services which are either consuming the application services from this particular app, or and the ME manager as well. that this particular application has gone down. So we need to use, we have to ensure that in my header, I should use a cookie with session ID and the reference ID that we got. Okay, again the connection establishment. This is again important for receiving the notifications from all the other services. And this is pretty much same as what we did in MEC Manager, except for one thing, that we still have to use the reference ID in the URL. Okay, this service activation API is an interesting one. So once I registers as an application, now if I want to consume any new services which are deployed in the system, I can still do that. All I have to do is fire a service activation request with again my service ID, and I'll get a response. I have to tell my platform what all services I want to activate for. So if you are authorized to use those applications, those notifications will start coming to you. For service deactivation, similarly, we just have to send the service ID, and that's it. And the reference ID, yes. So we again have to use the reference ID in all the. So whenever we are developing an edge application, we have to ensure that once my application comes up, it should first send the live indicator and get the reference ID, which has to be used in all subsequent requests. So it doesn't need to fire a live indicator every time before it sends, but once the application comes up. Okay, now let's see how do I know what all services are available. Okay, I register for some certain services, I'm able to activate the service, but how do I know which services are available for me to subscribe for? So there's another API called Service Discovery API, which helps me get the list of subscribable services from MEC platform. So it gives me a list of all the services which are available, and I can go ahead and register for those services and start getting notifications from them. This is how I subscribe the services. The subscription, the service ID which I want, and I can just send this details. Okay, if it is an integer, what service ID is, all the other parameters I can send out. Similarly, I can go and do some service data update and publications. If I have to publish some services, this is how I do it. So when I use this particular notification thing, so you can see that data update request. So for example, if one particular service wants to publish this information to all the other services which are listening to that particular data point. So once it will send to the MEC platform will check into the database, okay, which all services or which all applications wants this or are interested in this particular information, and they will send the notification to all of them. Okay. They were more of the MEC app APIs. Now the three important traffic rule APIs. How do I create a new traffic rule, and how do I create or update or delete a traffic rule? Now, when we see, I was talking about the traffic earlier, and what kind of an application we do have in here. So you can see that we have this producer app and consumer app, and who can produce it. So how the traffic routes from VM1, say VM0 and VM2 and VM3. So they all can go via my edge platform, or they can also talk to them directly, which is a standard case as of today, which is over the internet. But in this case, if they register itself with the Edge platform takes care of publishing it to all the application registered. Similarly, I can directly do a producer app and a consumer, they can talk to each other via WebSocket or a standard subscription with notification. So this is how we create a traffic rule. Again, I have to use my reference ID, and in the request body, in the result body, okay, sorry, I mistakenly write as a result body. That should be the request body. The request body should contain what kind of rule I want to create. So, for example, in this case, I'm showing what kind of an encapsulation this rules will apply. Say it can be GTPU or an IP traffic. Then what is a service IP that I'm interested in? So if it is, say, this particular service, if this particular packet is intended for this particular server IP, forward it to me. So it will go and forward that particular IP to that, the data to that particular VM. So what does it mean is, any traffic coming on DPDK port which is intended for 192.168.10.11 with an IP mask of 24, and if it is a GTP packet, please forward it to VM ID 2 with this particular MAC address. Similarly, you can do an update. All you have to ensure that the traffic ID which you receive here should be used while firing this API. Okay, before I move on, any questions? Boring or no?
An odd one.
Mm-hmm.
How is there security in all this? Is there security so that you don't have someone else sending your packets or saying something that you don't want?
Right. To be very frank, we haven't gone to that too much into the security yet. But yes, with the reference ID, this is one way of ensuring that the packet which is coming from, which is registered, the application which is registered, the packet is coming from there as well. So if it is intended for, say, ME app, unless until I have the correct reference ID, I'll not be able to send it to. So with the MAC address. So once the application registered, it also tells what is my MAC address and what is my VM ID. So based on that, it will keep on do the routing. But traffic who's sending it, say a UE. So okay, from the rule point of view, if you look at the rule says traffic coming from this particular IP or this particular or this kind of a protocol should be sent it to me. Yes. But if I can pretend to be that particular IP, there's no way I can avoid it as of today.
This API looks very similar to OpenStack APIs. So why are we developing something new and not just extend some of the OpenStack framework?
So this framework sits on the OpenStack itself. So this is one of the as a network function which sits on the OpenStack framework. I can say that, because ultimately the data plane is we are using the OpenStack platform to deploy this infrastructure. So the MEC manager itself will talk to the virtual infrastructure manager, be it OpenStack or anything else, and it can create. It has to basically deploy the VMs once you have to instantiate an application. So I'll use the OpenStack APIs to create the applications there.
Yes, it resembles very much.
Yes. Okay. Sorry. Any questions? No? Okay. Now. So there are two ways of handling this data at my application level. Once I get the data at my application, how do I handle it? Either I use my existing Linux APIs to receive and process the data, or I can use the L2 forwarding provided by DPDK. This is one of the examples how in which particular scenario, say in this scenario where my eNodeB sends out in data to NES for a particular VM, and if the VM has to send a response back to the VM rather than forwarding it to EPC. So in this particular scenario, what we need to do, we can use this, we can switch the inner destination and source IP address and send on the same port as my. So basically what I'll do is I'll get the source IP as source port and the destination port in the request, and just swap it and send the packet back. So I have to handle that during my application development. When I'm doing my application development at the edge, I need to take care of those things programmatically rather than doing it or relying on the L3 forwarding. This is just one way of doing it, but there could be many other ways. Okay, quick hands-on time. So I need help here. Sujata. Okay, so Sujata around. I'm done with the hand. Now we just handle one part.
Yeah.
So
I just need the mic to say goodbye to.
Okay.
You can switch the laptop.
Hi, thank you everyone who are there online. We'll be switching off the stream now because people in the room will be doing hands-on lab. So thank you for joining. I will continue for the people here.